In this video, we will introduce the covert triangle, which is used for determining the explosibility of gas mixtures. For example, if we would characterize the explosive risk of the following methane concentrations in air, and how do we know that? So if we have a 2% methane mixed with 20% oxygen, is it explosive? If we have 7% methane and 18% methane, is it explosible? And what about we have a lot of methane, 30% of methane, but only 5% oxygen, is it explosible? All right, by using the covert triangle, we can answer these questions. There are three important values on the covert triangle. The first one is the lower explosive limit. It is the minimum volumetric concentration required in air for the gas mixture to be explosive. And for methane, this value is 5%. The second value is upper explosive limit. This is the maximum volumetric concentration required in air for the gas mixture to be explosive. And again, for methane, this upper explosive limit is 14%. So if you have more than 14% of methane, it's not explosible. And the last value is the nose point. It is the minimum amount of oxygen required for the gas mixture to be explosive. And this value is 12%. And this table shows the lower explosive limit and upper explosive limit for some other common flammable gases. If we plot the three values, the lower explosive limit, upper explosive limit, and the nose point on this covert triangle, the lower explosive limit is here, the upper explosive limit is here, and the nose point is here. And again, here is the oxygen concentration in air. If we connect all these lines together, and we can divide this covert triangle into different zones. The first zone is in the middle. That's the red area. That's the explosive zone for methane. If we plot the concentration of methane, so that's the x-axis, and also we plot the oxygen concentration, that's the y-axis on this covert triangle, and that point falls into this area, then the gas mixture is explosible. And the next area is the pink area. That's the fuel-rich zone. That means you have too much methane, and it's not explosible, but can form an explosive mixture if you add more oxygen. And another zone is the orange zone. That is the fuel-lean zone. It can form an explosive mixture if you add more methane. So that means you have too little methane. And the last zone is the green zone. That's the non-explosive zone. It cannot form an explosive mixture no matter if you add oxygen or methane. All right, go back to this example. Let's plot the fourth scenario of methane mixtures on this covert triangle. The first one is methane 2% and oxygen 20%. 2% is here, and 20% is here. So if we plot that on this covert triangle, the point lies in that area. That is the fuel-lean zone. It is not explosive unless you add more methane to it. The second scenario is we have 7% of methane here and 18% of oxygen here. If we plot that on this covert triangle, it lies in here. It is in the explosive zone. So the gas mixture is explosive. The third scenario is 13% of methane and 5% of oxygen. 13% of methane and 5% of oxygen. Plot that point is here. It's in the fuel-rich zone. So not explosive unless you add more air or add more oxygen. The last scenario is 6% of methane, 6% of methane and 8% of oxygen. It's there. So that point, 8% is here. So 8% of oxygen. That point lies in there. It is non-explosive zone. Not explosive if air or methane added. Okay, by the end of this lecture, you should be able to use the cover triangle to determine if a gas mixture is explosible or not.